Hello everyone. So last time we discussed about bending formula, that was m upon I equal to sigma upon y equal to E upon r. Now in this lecture we are going to discuss some numericals related on bending formula. So let's take question number 1. A rectangular beam 60 mm wide and 150 mm deep is simply supported over a span of 6 meters. If beam is subjected to central point load of 12 kN, find the maximum bending stress induced in the beam. So in this question, first of all, we will see which type of beam this is. In question, it is clearly mentioned that the beam is of rectangular section. Width and depth are given, so by using width and depth we can calculate moment of inertia Ixx and y. So in case of rectangular section, Ixx equal to bd cube by 12. In this case b is 60 mm and depth d is 150 mm, so I equal to 60 into 150 cube by 12. Now y will be half of the depth, that is 150 by 2, that is 75 mm. Now since it is given that the beam is a simply supported beam with point load at mid, so when in this case the maximum bending moment M will be WL by 4. W is 12 Newton, that is 12 into 10 power 3. Length is 6 meter, that is 6 into 10 power 3 millimeter divided by 4. So M will be 18 into 10 power 6 Newton millimeter. Now using the bending formula M upon I equal to sigma upon y, we put the values, and in this way we can get the value sigma max equal to 80 Newton per mm square. Now in second question, a rectangular beam 300 mm deep is simply supported over a span of 5 meter. Here the beam is given as rectangular beam and depth is 300 mm. What UDL the beam may carry if bending stress is not to exceed 120 megapascal. Take I equal to 225 into 10 power 6 millimeter to the power 4. In this question we need not to determine the value of I, since it is given 225 into 10 power 6. It can be determined by depth by 2. Depth is given as 300 mm, so Y will be 300 by 2, that is 150 mm. Now the bending stress sigma equal to 120 megapascal, or we can say 120 Newton per millimeter square. Now by using the formula M upon I equal to sigma upon y, putting all these values, we will get M equal to 180 into 10 to the power 6 Newton millimeter. But we know that total bending moment in case of simply supported beam with UDL is given by M equal to WL square by 8. So we can equate this value of M to W into L square by 8. Now length is given as 4 meter, so we can say 4000 multiplied by 4000 into W divided by 8. So in this way we can calculate the value of load 90 Newton per millimeter. Now question number 3 says a cantilever beam rectangular with 80 mm width and 120 mm depth. So the section of beam is given as rectangular, 80 mm is the width and 120 mm is the depth. So we can calculate Ixx as bd cube by 12, that is 80 into 120 cube by 12, and y will be calculated as 120 by 2, depth by 2, that is 60 mm. So by using this data we can determine the value of I and y. Now if beam is subjected to a point load of 6 kN at free end and bending stress is not to exceed 40 megapascal, find span of cantilever beam. Now in this case the beam is given as cantilever beam and the load is acting at the end of the beam, that is at the free end. So in this case In case of cantilever with point load at free end, the bending formula maximum bending moment is given as m equal to w into L. By using bending formula m upon I equal to sigma upon y, we put the values m as 6 into 10 power 3 into L divided by I as BD cube by 12, 80 into 120 cube by 12 equal to sigma is given as 40 megapascal, so we can say 40 Newton per mm square divided by y is 120 by 2, that is 60. So in this way we can calculate the value of length as 1280 millimeter, or we can say 1.28 meter. Now let's take question number 4. It says a hollow steel tube having outer and inner diameter as 100 mm and 75 mm is simply supported over 5 meter length. So section type, hollow circular type with outer dia and inner dia as 100 mm and 75 mm. So by using this data we can calculate the value of I and y. I will be for hollow circular section I equal to pi by 64 d naught to the power 4 minus di to the power 4. D naught is given as 100 and di is given as 75 mm. So in this way we can calculate the value of moment of inertia about neutral axis I. Now y will be out half of outer dia, that is 100 by 2, that is 50 mm. So by using this data we can calculate I and y. Now it is said that beam is simply supported over 5 meter length and tube carries a point load of W at 2 meter from one of the supports. Now since the load is at 2 meter from one of the supports and total length of beam is 5 meter, so in this case the beam is offset, that is m will be taken as m equal to WAB upon A plus B. Here A is 2 meter and B is 3 meter, so we will calculate m equal to WAB upon A plus B, that is 1.2 W into 10 power 3 Newton millimeter. Now using the formula m upon I equal to sigma upon y, we can get the value of W as 430.5 Newton. Now let's take question number 5. River 3 meter long is subjected to a UDL of 30 kilonewton per meter. So it is a cantilever with UDL, that is m equal to WL square by 2 will be taken as maximum bending moment. W is 30 kilonewton, that is 13 to 10 power 3 Newton, and length is 3 meter. So 3 square by 2, that is 105 into 10 power 3 Newton meter, or we can say 105 into 10 power 6 Newton millimeter. So we will stress sigma is given as 15 Newton per mm square. If cross section of beam is rectangular with height double than width, determine the dimensions of the beam. In this case it is given that beam is of rectangular type and depth is twice the width. So like in figure, if width b, then height will be twice of b. So I will be bd cube by 12, that is b into 2b whole cube by 12, that is 2b to the power 4 by 3, and y will be in this case 2b by 2, that is b. Now putting all these values in bending formula, m upon I equal to sigma upon y. So in this way we can calculate the width as 230 mm. Now since the height is twice of width, so height will be twice of 238, that is 476 millimeter. In this way we can design any beam. This is also called the designing of a beam. All these data will be given and you will be asked to design the beam. Designing means you have to calculate the width and height or depth of the beam. So here we are having the last question. A rectangular beam of 200 mm width and 400 mm deep. So here the beam is given as rectangular with width and depth. So I can be calculated as I equal to BD cube by 12, that is 200 into 400 cube by 12, and y can also be calculated as half of the depth, that is 400 by 2. So by using this data we determine the value of Ixx and y. Now it is simply supported over 4 meter length and carries a UDL of 10 kilonewton per meter. So in this case the beam is simply supported with UDL, that is maximum bending formula M will be equal to WL square by 8. W is given as 10 kilonewton, so 10 into 10 power 3 into L square, that is 4 square divided by 8. So we have got the value of M as 20 into 10 power 6 Newton millimeter. Now uh, putting all these value in bending formula M upon I equal to sigma upon y, we can easily determine the allowable stress sigma as 3.75 mega Newton per meter square. So students, if you like the content, please like and share the video, and for much and more interesting videos, please subscribe the channel and don't forget to press the bell icon. Thank you.